Happy hour. Thank you so much for coming. It's been a really exciting week here at Space Symposium and at the Redwire booth. Last tech talk, but certainly not least, we're talking today about how enabling space commercialization in LEO. And we have a lot of heritage in this and a lot of conversation that we can have around this topic. So I'm really excited to introduce you our speakers. General Manager of Redwire Mission Solutions, Justin Kugler, and we also have Alicia Carey, who is the lead program manager for Redwire as well. So with that, I'll pass it on to Justin.
All right. Thank you, Terry. So, at Redwire, LEO commercialization is something that is, very near and very dear to us. It's really in the DNA of who we are and what we do as a company, stretching back to the very origins of Maiden Space, running up until our acquisition last year and running through what we do today. It's something that's very personally important to me, having helped grow the ISS National Laboratory and its portfolio, and really setting the stage for the work that we're doing now on the International Space Station and with our commercial partners to advance this frontier and make it more accessible and actually start bringing microgravity and low Earth orbit development into our economic sphere of influence. And it's Alicia's team and our Jacksonville, Florida facility that's really doing that, nuts and bolts work every day to make this vision come true and make it become a reality. So today what we'd like to do is talk with you about the actual work that we're doing to bring LEO commercialization to the forefront, and how we're working with NASA and our commercial partners and commercial space transportation friends to move things out of the lab and into commercial production.
Yeah, thank you, Justin. We've had such a great partnership with NASA. They've supported us on all of our material science experiments. Basically, we started the journey with ceramics. So this is our most recent development in material science. We launched the very first SLA printer to space. We created the very first ceramics in space. This was earlier this year. Basically, the idea is we want to be able to print in space with multiple types of materials. And we want to be able to improve those materials and bring them back down to Earth to create a new type of industry. So ceramics, if you've ever worked with a pre-ceramic resin, you'll know that there's a problem with a sedimentation effect. So you're creating the part, you're going to have probably not a uniform distribution of the strengthening aspects of that resin. So in the microgravity environment, you remove that sedimentation effect. You create the opportunity to have a uniform distribution to create a stronger part, a part with fewer imperfections, and therefore a part that can be used on Earth in high heat and high speed applications. So we're looking to improve materials by creating them in space, and then work with partners on the ground to actually apply that to their technology. And that's just one. We're going to relaunch that experiment on Saturday. So everybody get up early, 3:14 a.m., SpaceX 23, launching from Kennedy Space Center. Justin's nodding at me because I have so much to talk about. We actually also launched a inorganic crystal experiment. We've grown 2 crystals so far. The idea is that, again, that sedimentation effect causes so many problems. We're growing crystal in a solution-based environment. These crystals can be used for laser lenses with medical applications, and we found that as we're putting that laser energy through the crystal, again, those cracks, those imperfections, keep the laser from using the lens in a way that it has a long-term success. So if we create products like this in space and create laser lenses for the Earth, we'll be able to use them for longer and probably more increased energy applications. So we have a 3rd material science experiment going up in December, and we're actually going to be heat treating some metals. So again, looking at what the microgravity environment can do to strengthen and improve metals, and we'll get those results early next year.
And something that I think it's really important to emphasize is that they're doing amazing work, and it is really cool science, but it's not science just for the sake of science. what is unique about the way Redwire approaches LEO commercialization is our focus on solving real problems for real user communities here on Earth because they can't get those solutions any other way. We've developed a process of both industrial technology and business development such that we look at the holistic end-to-end value chain. So first we determine from a physiological, phenomenological perspective, can you get improvement by doing your processing in microgravity? That's the entry step. Then we look at the actual process parameters. Can you actually produce useful amounts of product using the infrastructure and resources that we have available today, like the space station, like the SpaceX Dragon vehicle, soon to be Dream Chaser from our friends at Sierra Space. How can, if you can only make 1 kilogram of useful sellable material a year, your market is too small. But if you have to generate 10,000 tons of material a year to close the business case, then that's too much. We've got to hit that Goldilocks zone where the addressable market and the production capacity all line up so that we can close a business case. And then once you've determined that, you can actually get beneficial product improvement from microgravity development, that you hit that Goldilocks zone, that's when we then move into the process development phase where we figure out what works and what doesn't work. Because I'll tell you what, I've worked on space station payloads and programs for over a decade now. First at NASA, then at CASIS, and now at Maiden Space and Redwire. And the microgravity environment behaves in very non-intuitive ways. And so that's one of the tremendous benefits from product development, but it also makes it extremely challenging and also rewarding for our development engineers that are figuring out how to actually harness this incredible environment and put it to work in these product development applications. And it's really exciting because we're now in that proof of potential phase where we're proving out that we can take this fundamental science, translate it into an industrial process, create minimum viable products, and then use that to accelerate the growth of future LEO platforms, future transportation infrastructure, all those things that we need so that we can actually start really turning the crank, creating factories in space, and delivering useful product to people back here on ground, and actually materially improving their lives through these new products and new services that are being created.
Yeah, I'm glad you brought up services, Justin. We're also developing a freezer. If any of you have been following some of the more recent launches, there's a limit on the amount of freezer and refrigeration space on those spacecraft. So we've been working to solve that problem to create an unpowered freezer to keep those samples safe, both going to the space station and coming from the space station. Dragon capsule's always strapped for space, so all those plugs are usually taken, which is why we focus on unpowered. And so we want to make sure that we are providing that service to NASA. It's a very unique model in that NASA has not purchased this freezer. We're actually going to be the company that is providing the freezer, providing the service, and they have purchased just a certain number of launches from us. Once we get that proof of concept out of the way, we'll most likely extend that contract and hopefully have freezers on every launch.
And I'm glad that Alicia brought up that aspect of it well, and that having great technical excellence is the entry gate to being successful in LEO commercialization. Another really big part of what we're doing at Redwire is changing how the business of space is being done. So, for example, like she mentioned, with our Olaf freezer, we are providing that as a service back to NASA. We own and operate the hardware as a commercial platform. We will continue to do that over the remaining life of the space station and onto future platforms like the Sierra Space Life Habitat, like the Axiom module that's in development now, and actually make it easier and more sustainable to do these kind of long duration mission operations in low Earth orbit. On top of that, we're also starting to look ahead at how we can take advantage of the fact that as Redwire continues to evolve as a company and take advantage of new capital markets and financial instruments, we can actually work with end users and customers to define their needs, define a path forward, and then use private financing to build these capabilities, deliver them. And that way we can do it more quickly, more affordably, so that our customers are looking at this as an operational expense instead of a capital expense. And that's how we can actually really start growing this market and growing these capabilities and moving the technology forward, all in a mutually beneficial, mutually acceptable path.
Yeah, and it's not just going to the space station and coming back to Earth. We definitely want to establish that market, but we also find a real benefit in using the space station as a learning platform. So working with our customers to understand what functions in microgravity before we send it to the moon and before we send it to Mars, before we send it to cislunar. We're actually printing today the very first regolith on the space station, I think, in microgravity environment. So understanding what lunar soil does when we 3D print it, understanding how to create a in situ resource with a binder to create actual infrastructure. We're working on that right now today. We'll have 3 prints and bring it back to Earth. Partnered with the amazing Material Science Lab at Marshall Space Flight Center to understand what forces we can put on that, and then we can actually tailor what we 3D print to what that product's going to be, and create machines that are more accurate and have a higher success rate to move beyond Earth and beyond LEO.
On top of that, I think it's really important to emphasize that through all of this, we've had an amazing partnership, an amazing relationship with NASA. They were our very first customer when we built 3D print and sent that to the space station in 2014, where we did the very first manufacturing off-world. They've been one of our most important customers through the ongoing operations of our additive manufacturing facility, which again we own and operate as a commercial service, and where we return that value back to NASA. And they're already looking ahead, for lessons learned from space station operations, from COTS and CRS, and ahead to what we're doing in low Earth orbit, so that as we go forward to the moon through the Artemis program, we have that commercialization and that collaboration between government and industry built into the system from the very beginning, so that NASA can focus on its missions, like scientific exploration of the lunar South Pole, like figuring out what resources are in permanently shadowed craters, like figuring out how to do radio astronomy on the far side of the moon, where we're constantly blocked from radio noise from the Earth. And we and our commercial partners and friends are providing that infrastructure that makes it affordable and sustainable to continue doing those operations. Hopefully, for the rest of my lifetime, and I really truly believe that if my kids can choose to live and work in space, whether that is doing work as a commercial astronaut on a future LEO platform, or running the Artemis base camp. If they can do that just as easily as they could choose to go, work in oil and gas exploration or go work at McMurdo Station in Antarctica, I feel like we'll really have succeeded if that choice is just as accessible for them as what we're doing here today at Redwire has been for me and Alicia.
Yeah, exactly. And we always want to champion that original platform, because when you go to austere environments, you never know what you're going to need. So that could be inside the space station, outside the space station, and anywhere beyond. Having the ability to create exactly what you need when you need it, not have to depend on supply chain, not have to depend on all of the machinery and the subcontractors agreeing on all the screw sizes. We really want to make sure to serve that greater purpose, and to make sure that whatever effort we do, we're there in support, and we help facilitate that.
Well, and I think that becomes ever more important as we continue to push back the boundaries and get further and further away from Earth. Looking ahead to the future, the moon as a launching pad for going on to Mars and the outer planets. The further we get away from Earth, the more self-sufficient we have to be. And all of these technologies, all of these capabilities, this is all foundational towards building that infrastructure, expanding humanity's reach out into space, expanding our experience of the universe and our place in it, whether that's building solar power farms so that we can reduce our carbon emissions, combat climate change, and actually create an energy-rich future in which everybody can live and work and be happy and pursue their bliss. Whether we're talking about obtaining resources from extraterrestrial sources so that we don't have to go into the rainforests and extract what we call on our planet rare earth metals, but are actually in tremendous abundance elsewhere in the solar system. All of this is about putting the resources of the solar system to work for humanity so that we can create that fantastic future where we all get what we need, we all get to live the way we want to live, and the universe is really opened up to us. Whether that is taking vacations to the moon, or going and doing exploration missions on Olympus Mons. And personally, it's my hope and my dream that one day I'll get to see Jupiter and Europa with my own eyes. Or in the case of our friends in the planetary and exoscience communities, building the capabilities so that we can actually do direct imaging of other worlds and actually see what other planets around other stars look like, and maybe even figure out that once and for all, maybe we're not alone in the universe. And what does that mean? All of these technologies that we're working on at Redwire to commercialize low Earth orbit, to put space to work for humanity, these are all those foundational capabilities that unlock that amazing future that I am very confident, and I very strongly believe that we'll all see that in our lifetimes.
Yeah, I couldn't have said it better. Cool. All right, so I think we have a couple minutes for questions. If Terry wants to grab anyone who has a question about LEO commercialization, we're happy to answer.
Hi, so I'm just really fascinated with the regolith printing. I think that's just a fascinating deal because there's just so much of it right on the moon. So what does that look like future business model-wise for you guys? Is it totally automated production? Is it by-wire production? Is it people on a station in space doing manual production? What does that look like? Or is it a mix?
Yeah. No, that's a great question. I do think it is a mix, in part because really what we're figuring out how to do is use regolith essentially as a bulk aggregate material for a wide variety of applications. With the Redwire regolith print that we have on board Space Station right now, that's really an adaptation of the fused deposition modeling based processes that we've been doing on the Space Station for over 7 years now, and that's something where you can do things like patch holes and repair joints and seals. But at the same time, we're also looking at how you can create bricks and pavers so that you can build permanent infrastructure that actually naturally blends in with the environment, which actually makes it easier to do things like thermal control and debris mitigation. But at the same token, you've also got to be sure that if you're dealing with human operations, that we're not creating construction materials that make it harder to maintain a safe, controlled, and habitable environment. So we have to adapt the processes to those various applications, whether we're talking about landing pads so that we're not sandblasting our habitats every time a lander comes in or takes off, or building equipment garages so that our equipment can survive the lunar night, and so that we can mitigate total radiation exposure over the life of the equipment, all the way to building permanent habitats for people to live and work and do their jobs when they go to the moon. the regolith print experiment is again that foundational work so that we understand how this material behaves in that low gravity environment, and using that foundational information, we can then branch out into all those different applications.
Any other questions?
In the area of mining rare minerals, do you see that as a surface application? Is that a subsurface application? Will that be a drilling? Will that be an underground operation? And what is your opinion on that moving forward?
So I do think that very much depends on the end use. And behind all of this is what is the energy opportunity cost of your chosen approach. So, for example, I'm personally skeptical that we will ever mine helium-3 on the moon, put it on a rocket, and ship that to Earth, because the energy cost of transporting that material is higher than that material is actually worth by itself. But if you can extract helium-3 and use it as an industrial gas on the moon, so that you can build higher value products on the moon, because the energy cost of getting them off the moon and into space is so much lower than doing it on the Earth, that's how you start building a virtuous cycle. And so, for example, and again, it's like looking at what are your delta V costs to move a raw resource to a place where it can be useful. And so, like, for rare metals, if we do mine those like on the moon and on Mars, it's going to be to use it at the moon and on Mars. But then if we're looking at near Earth objects that are in really stable gravitational points with respect to the Earth, the energy cost of bringing those materials back to low Earth orbit, so that you can build spaceships that never land, so that you can build O'Neill cylinders, so that people can live and work in space without worrying about microgravity breaking down their bodies and making their eyes bulge up into their skull. That's how we start affordably building that infrastructure so that we can expand our sphere of influence.
Thank you for that. I was going to ask a question similar. I was going to say, outside of helium-3, what do you think is like the business case for lunar development?
So I think at the beginning it is going to be providing those services and infrastructure for sustained science and exploration campaigns. I think it'll be very similar to how we're trying to do sustainable, environmentally friendly exploration of Antarctica and other pristine environments. But I over time, and as we get that infrastructure in place, I think we'll find that the moon has really strong potential for being an industrial park. So that instead of having to tear down forests and rip raw resources out of our ecosystem here on Earth, we can build things on the moon, take advantage of the lower gravity well to send those into space, and then get that virtuous cycle going where we can build much larger space infrastructure than what we can do today, and continue building up capability, expanding our reach, and building up capability over time.
Thank you.
I'm really fascinated by that vision, and I think the moon should be a launch pad to anywhere in the solar system, and that it's definitely the next Silicon Valley. So in terms of the timeline, when do you think we can have the first in-situ resource utilization and 3D printing operation on the moon? And when do you think we can reap commercial benefits from this? Yeah, that's it. Thank you so much.
No, that's a great question. Really from a technological perspective, if we had the right customer, we could put this equipment, on Eclipse lunar lander, or on future human landers, tomorrow. assuming that we get through the safety and integration process. The technology is there. What takes longer is really development of the business cases and the adoption cycle. So for example, if you look at the work that Clayton Christensen did on the tech hype cycle and adoption curves, we're still very much in that stage where we've got to find those early adopters that are willing to take certain technological risks because it delivers a capability that they can't get anywhere else, or it satisfies a strategic or intrinsic need that they can't get anywhere else. And I think for now that really is going to be science and exploration, and we use that to get people interested, get people involved, unlock those other opportunities, and we build on those as we go forward.
Okay, any other questions from the floor? No? Okay, any closing remarks from you guys? Oh, we do have one more question. Sorry.
Hello. So I am wondering what is necessary for the data infrastructure for all of these operations to proliferate.
Now, that's a great question. Especially as we're looking ahead towards building truly self-sufficient space infrastructure, and as we're moving farther and farther out from Earth, where we need more independence in operations. I do think that's going to require moving a lot of that computing and automation capability onto those platforms, because it doesn't make sense to have to do a lot of data processing on the ground, send that up to orbit, bring it back down, and do that constant back and forth. What we really need to do is to get to that point where, say, a ground controller says, this is what I want my platform to do. It sends the command, and then the platform or the factory or whatever it is says, okay, I've received these commands. These are the resources that I have. These are my operating conditions. This is what my current environment looks like, and it autonomously processes that information, executes the commands, and delivers that result, whether that is a new data product generated by an on-orbit platform, or it is a spool of Z-band fiber produced to a certain set of specifications and quality standards, or it's building a replacement part for a human habitat. I think we're going to have to move a lot of that infrastructure on orbit so that we can keep those latency rates down and increase the speed of response.
Yeah, thank you. I just want to say that Redwire is an incredibly agile company, and we're going to do absolutely everything we can to support space for Earth as well as space for space. Prep that environment for the next man and the first woman on the moon.
Amazing. All right, thanks everybody.
Thank you.
We have all survived Space Symposium, so cheers to everybody. Thank you so much. Be sure to follow us on our social channels at Redwire Space for continuous updates about what's going on at Redwire, what's going on in the industry, and we hope to see you all next year. Okay, bye everybody.
Thank you.